All right, Math 30s. This is lesson 4 of set theory. So it says applications of set theory, Venn diagrams part 2. It's kind of part 3, whatever. Um, Obviously, got to keep going this way. So our Venn diagram, so now we have 3 different sets. So we have aliens and they have taste for flesh. They want death to humans and they have advanced technology. Whereas zombies have a taste for flesh, are looking for death to humans and have no emotions. Robots have no emotions. They're looking for death to humans, and they also have advanced technology. So that's our Venn diagram of zombies, robots, and aliens. Onto the lesson now. So make sure you've watched the other 3. So it says, in each of the following Venn diagrams, shade the region that's indicated. So A and B. So thinking to yourself, is that talking intersection or union? Try shading it in quickly on your sheet. What would be A and B? Again, here we have 3 sets. So we want the intersection of A and B. And so that would be this part here. That's everything that's in A that's also in B. A or B. So again, and was our intersection. The way that we also could have written that is A intersection B. A or B. This is the union. So it's anything that's in A or in B. So that would represent the union of set A with set B. A and not B. So that's things that are in A but not in B. So if this circle here is representing B, we know it can't be anything there, and it needs to be things within A. So A and not B would be this guy, because again, those are things that are in A that are not in B. A and not B and not C. So it's tying together, this is the last one, but now it's also saying that we don't want anything that's in C. So in that case, it's going to be close, but now we're not actually going to have anything that intersects with C. So it would actually be that portion is what is A and not B and not C. So you should be able to shade those types of diagrams. So the Venn diagram on the right displays results of a survey of 100 families regarding technology in their homes. Oh my gosh. It must have been a survey from, you know, the 90s, let's say. So C represents the number of families with a computer. V represents the number of families with a VCR. F represents the number of families with a fax machine, and S represents all the families surveyed. So that would actually represent our universal set for this. But yeah, there's some old stuff, VCRs, fax machines, you know, the stuff I grew up on because I'm old. So it's colored in here. I know it's not in yours. So this kind of blue circle here is representing C, which is computers. Pinky purple, I can't quite tell, represents fax machines, and V represents VCRs. So what percent of the families have a computer at home? So we have 100 families surveyed. That's again, all of the families there. So we know out of 100, how many families have a computer at home? So it's too bad because it tells us right here. But if it didn't say C equals 78, we could add up 62 plus 7 plus 5 plus 4. That would get us to 78. So that's, again, 78% of families have computers at home. How many families have all 3 machines at home? So that, if we wanted to write that out, that would be the intersection of C and V and F. So Again, that's the intersection. What's in common with all three? Because it's saying all three machines. So the intersection, there's 5 families out of the 100 that have all 3 machines in their home. How many families have none of the machines in their home? So again, this chart, I wish I could erase this and this and this, and for right now, erase that. If we didn't have that piece of information, we could take all of these numbers, subtract them from 100 to get the value that I've now crossed out and can't see anymore, but it would be 3 families have none of the machines in their home. So again, 100 subtract all of the numbers that are in here. We can't do 100 subtract this and this and this, because then we're going to end up with a negative number because we're counting things more than once in these intersections in the middle. How many families do not have a fax machine? So if we're looking at fax machine, this is our circle for fax machines. So we could say 10 families do. So 100 subtract 90, sorry, subtract 10 is equal to 90 families do not have a fax machine. Or we could add up 7 plus 62 plus 18 plus that 3 that's down here. How many families have a computer and a VCR? So again, what that's saying is the intersection, because it has the word and, computer and a VCR gives us, let's look back up here. So computer and VCR. So again, the intersection of computer and VCR is this section. Sorry, I've kind of written over this portion. Can I back up? No, it won't let me back anything up, but it's the intersection of those two. So that's going to be 67 individuals or 67 families have a computer and a VCR, because these people have a computer and a VCR, but also those ones at the triple intersection have a computer and a VCR. They also have a fax machine, but that doesn't really matter in the context of that question. All right, so this is getting into kind of trickier ones. It says each member of a sports club plays at least one of soccer, rugby, or tennis. So I'm going to just start out soccer, rugby, or tennis. The following information is known. So 43 members play tennis. I'm going to do this like the last one. So 43 members play tennis. 11 play tennis and rugby. I can't really represent that on here right now. So 11 play tennis and rugby, which would be right here. 7 play tennis and soccer, which would be right here. 6 play soccer and rugby, this portion. 84 play rugby or tennis, which would be all of this part. Sorry, I can erase once I circle stuff, so I'm just dragging my cursor. So that would be rugby or tennis. 64 play soccer or rugby, so that would be within those 2 top circles. And 4 play all 3 sports. So I know that I can actually write that one in first. 4 individuals play all 3 sports. So we're going to start here at your intersection of all 3 parts. The next point that's easy to do, easy-ish to do, is so you started with that last bullet point. Oh, please 1 second. So 11 played tennis and rugby. So tennis and rugby again, if you can see my cursor, tennis and rugby are this part. We're saying 11 do that, so we've already accounted for 4 here. These individuals do play tennis and rugby. They also play soccer, but we've already counted them. So for just tennis and rugby, there's going to be 7 individuals there. I'm going to just kind of cross off ones that I've done. So 7 play tennis and soccer. So tennis and soccer would be this says 7 play tennis and soccer. We've already accounted for these 4 that play tennis and soccer. So it's just going to be 3 for just tennis and soccer. 6 play soccer and rugby. So soccer and rugby, this portion, already accounted for 4 there. So there's 2 that play just soccer and rugby. Continuing to work. So we can't do this one. It says 68 play soccer or rugby because we have 2 unknown spots right now. So we can't go to that one yet. 84 play rugby or tennis. Again, can't do that because we have 2 unknowns. So up to that first one, it says 43 members play tennis. So we know that this whole circle for T needs to be 43. So if I subtract those intersections, we can get what the individuals that just play tennis or only tennis. So 43 subtract 7, subtract 4, subtract 3 is equal to 29. So there are 29 individuals at the sports club that play only tennis. So now we've done this one. We can go to this rugby or tennis part. So that's 84 people play rugby or tennis. So 84. I'm going to subtract the 43 from tennis, right? That's this whole circle here. So 84 subtract 43 subtract 2 will get us 39 individuals that play only rugby. So again, this 84, if we add up, I'm going to draw because then if we add up the numbers in there, that will add up to 84 now. What if I do this? Oh, wrong screen. Oop. Okay. That's kind of a pain though, so we're not going to do that again. And the last one we can figure out, so 68 play soccer or rugby. So we could go 68, subtract 39, subtract 2, subtract 4, subtract 7. That gets us 13 individuals that play only soccer. So that's figuring out your Venn diagram. So question B, so again, that's part A there. How many members does the club have? So you'd need to add them all up. And that's based on how the question is worded up at the top there. It says each member of a sports club plays at least one of these things. So we've accounted for all of the members in this case. So if we add all the numbers up, we get to 97 members. So you can see how this kind of ties in that logic and reasoning situation. And as I said, those numbers and or seem not substantial, but they are so very important. So you just need to make sure you understand and versus or, intersection versus union, what that actually represents on a Venn diagram. Ooh, I'm frozen right now. So the Venn diagram represents the results of a survey of 100 students. So P is the number of students, or set P is the number of students with a cell phone. Set C is the number of students with a computer. Set D is the number of students with a DVD player. So looking at that, it's given us our pieces of information. Phone, DVD, and computer. So how many students own only a cell phone? So again, the word only, it's telling us no DVD or computer. Only a cell phone would be this portion right here, those individuals, because these individuals have a cell phone, but it's not only a cell phone because they also have a computer. So 3 students have only a cell phone. How many students own a cell phone? So now we don't have that restriction with the word only. How many students have a cell phone? So now we're looking at this whole circle for P. So how many students have a cell phone? 11. Maybe this was taken in like 2000, let's say, maybe 1999 or something like that, because it would shock me that only 11 out of 100 students would have a cell phone, but like a ton of them have computers. I don't know. It's peculiar. I like these weird data sets. Um, so yes, the way I got 11 there, if I didn't say that, 3 plus 6 plus 1 is 11. So how many students own a computer and a DVD player? So computer and DVD, again, the word and is telling us the intersection of those. So these students, these 6 students have a computer and a DVD player. They also have a phone, but they definitely have a computer and a DVD player. These students have a computer and a DVD player. So in total, 8 students there. I guess I should write some of these things just if you're, so 3 plus 1 plus 6 plus 1. This would be our 2 plus 6. How many students own a computer or DVD player? So now the or is anything within what I kind of have outlined up there. So that would be 68 plus 1 plus 6 plus 2 plus 17. That would get us 95. So 95 out of the 100 students have a computer or a DVD player. How many students own all 3 items? So that's the intersection of all 3. And so the intersection of P, D, and C would be 6 students. How many students do not own a cell phone? Do not own a cell phone. So you could add up everything that's not in this piece. You could add 68 plus 2 plus 17. Don't forget about this 2. This 2 represents none. So don't have a phone, don't have a DVD player, and don't have a computer. The way I immediately think about it is we knew 100 students, subtract DC and Part B, we said how many students own a cell phone? We said 11 own it. So if we go 100 subtract 11, that's 89. But again, you could also get there by adding 68 plus 2 plus 17 plus 2. That's also 89. What does the 2 outside of the circles represent? I guess I just defined that, but that's 2 students that don't own any of the devices. All right, so one more here. So the members of a book club read fantasy, mystery, and adventure books. The following Venn diagram shows the types of books that the members like. So the members like fantasy, mystery, or adventure, or all of them, or some subset of them. This one's pretty straightforward, actually. It says use the diagram to determine the number of people who read fantasy or mystery, but not adventure. So again, words like not versus or. So fantasy or mystery, if it just said that, this would be fantasy or mystery, but it's specifically saying not adventure. So these people like adventure books, these people like adventure books, and these people like adventure books. So in order to find fantasy or mystery, but not adventure, 8 plus 15 plus 9, and that's equal to 32. Now I really can't erase things and I've made a terrible mistake. Adventure or fantasy, but not mystery. So adventure or fantasy, so same idea. This red circle, this tan colored circle, but not mystery. So the things that are not in the blue circle. So that would be our 9 at the top, 11 that has an excerpt from the last question, and 7 gets us 27 individuals that like adventure or fantasy but not mystery, and neither fantasy or mystery. So those would be, so all of these are in mystery, All of these are in fantasy, so that would be our adventure only. That would be 7 individuals. Since there's nothing in our universal set, maybe people that only read um, Guinness Book of World Records, that's their favorite books, that could be outside of this. Since it doesn't give us any information, we only go with what we have, so adventure only. So you have your last set of problems. I have a special note in my notes that question 2 on the next one is tricky. So the hard part is you don't get your intersection of all 3, and you need to think about how that portion ends up being counted 3 times when you're working from the outside to the in. So number 2, it is tricky. I fully understand that. It's a hard one to get through, but see what you can do with that. The other ones should all be fine. So question 1 and question 3 should be fine. I'll let you, or you'll need to look into the assignment as well that you'll need to submit. So that's it. That's all. Talk to you later, guys. Bye.